So while you're doing the warm-up, just know that you should have two worksheets now. First worksheet you got last Friday. Second worksheet you should have picked up yesterday. Some of you have them on two separate sheets. Some of you have them on one sheet. Okay? But you should have two different worksheets. On some of them yesterday, I made a mistake copying them off, and I copied the same one twice. And so I just put them on the back side, so your two worksheets might be on one piece of paper. Okay? Then there's a warm-up down here for you guys to start. So today we're going to solve some equations. We're going to take simplifying expressions, which is what we've been doing. We're going to take it to the next level, and we're going to solve equations with it. And then your test is going to be a week from tomorrow. All right. So if I'm going to be simplifying here, tangent cosecant squared over cosine cotangent, first thing that I'm going to want to do is I'm going to say, well, one thing we noticed yesterday, and this wasn't just me noticing it, all three of us noticed it when we were correcting our formatives, was the fact that, yes, this expression is there, but if you're going to take just one part of it, you still got to have all the parts with it. So like if I'm going to change, what I mean by that is, if I'm going to change the tangent of x to sine over cosine, because that's what tangent is equal to, right? I can't just say here sine over cosine. I've got to give the rest of the problem too. Okay? Now, can I do all of these changes at the same time? By all means, I can do all of these changes at the same time. Cosecant squared would be 1 over sine squared. Cosine is just going to be cosine. Cotangent is going to be cosine over sine. I can't just do one of those off to the side. I have to maintain the expression all the way through. Okay? Now, a couple of different ways to do this. You could simplify the numerator, you could simplify the denominator, and you could go forward. Or you can say, all right, so I've got the sine of x. Actually, here, let me color code it still. You've got the sine of x over cosine of x. You've got 1 over sine squared of x. That's my numerator. That was the keep part. The change part says instead of dividing, now I'm going to multiply. And then the flip, I got to flip both of those on the bottom. So cosine becomes 1 over cosine. Cosine over sine becomes sine over cosine. On top, I get sine squared. On the bottom, I get sine squared cosine cubed. Sine squared cancel each other out. Leaving me with 1 over cosine cubed, which would be secant cubed. Okay. So today we're going to take that, but instead of just simplifying the expression, we're going to solve an equation now. We're switching from expressions to equations. We're going to solve the equation, and we're going to go first lap of the unit circle. We're going to start at 0, and we're going to include 0 in any and all solutions. And we're going to go first lap. We're going to exclude 2 pi, meaning if you got an answer here later on, you'll see, like if I had cosine equals 1, where does that happen? It happens at 0, yes. It happens at 2 pi, yes. But we're only going to include the 1, 0. We're not going to include the 2 pi. So we're inclusive on 0. We're exclusive on the 2 pi. Okay? If I'm looking at this one, 3 cosine of x minus 2 equals cosine of x, what I'm thinking, my think box is telling me 3y minus 2 equals y. The trig function is your variable. Okay? Our trig function now becomes our variable. So when we would solve 3y minus 2 equals y, we would get y's on one side of the equation and numbers on the other side of the equation. Now, same thing. But now we're going to get cosine, because that's our variable, cosine of x. We're going to get that on one side of the equation, and we're going to get the numbers on the other side of the equation. Okay? So if this were me, I would, in this particular case, I would here subtract 3 cosines of x. Just like way back up here in this algebra one, I would have subtracted 3y from both sides. When I do that, I get negative 2 equals negative 2 cosine of x. Just like up here in this algebraic one, I would have gotten negative 2 equals negative 2y. Now what? Divide by negative 2. Okay? So now I'm going to divide both sides here by negative 2. That's going to give me positive 1 equals cosine of x. Once you have your singleton trig function equal to some number, now you go to the unit circle and you ask yourself, where on the unit circle is cosine equal to 1? Okay. At 0, right? Okay. Now this would be that example that I would just reference before. We're including 0, we're excluding 2 pi because they're at the same spot. Okay. So the answer here would just be x is 0. And 0 radians. Actually, I don't even want to say x equals there. I'm just going to say 0. Because that's the angle that would solve that equation. You try that. So here I would subtract cosine. And at the same time, I would subtract 2. So that would give me 2 cosines equals -1. Divide both sides by 2. That gives me cosine equals -1/2. So where on the unit circle, first lap, does cosine equal -1/2? 2 pi over 3, yes? Is that it? And 4 pi over 3. Okay? So there will be multiple answers. In some cases. Because in both of those cases, the cosine is -1/2. Okay? Good times. Good times. Try that one. Right? -1 over the square root of 2 is -√2 over 2. Sine is equal to -√2 over 2 at 5 pi over 4 and 7 pi over 4. Agree? Ruh-roh. What's different in this one? There's not two identities, but two trig functions, right? Okay. So there's two trig functions in this particular case, which means we have to tweak how we do things. Okay. Now, if possible, we could combine the terms, right? Or I shouldn't say combine the terms. Simplify the terms. Okay? However, if we would go down that road here in this particular case, it wouldn't necessarily get us anywhere. Okay? So instead, we can always do that dreaded F word. Okay? We can factor out a tangent. Agree with my factor. Okay? Once we have it factored, then we have what's called the zero product property. Now, you probably don't remember what the zero product property is, but you know how to use it. Or remember that it's called the zero product property. Okay? The zero product property says that if I've got something that's factored and it's equal to 0, then one of the factors or both of the factors must equal 0. Because the only way that you can multiply to be 0 is if one or all of the parts are equal. Okay? So now we're here. So now I'm like, okay, tangent of x equals 0. Where is tangent, bless you, first lap of the unit circle, where is tangent equal to 0? 0 and pi, right? Because it's sine over cosine, so it's y over x. So I need my y to be 0, so that would be at 0 and pi. Then I gotta go through and I gotta solve this one. Add 1 gives me square root 2 cosine of x equals 1. Divide by the square root of 2 gives me cosine of x equals root 2 over 2. Where first lap unit circle is cosine of x root 2 over 2. Pi over 4 and what? And 7 pi over 4. So this particular one has 4 answers. In all 4 of those angles, that is a true statement. Yeah? So it's not, we can't follow the degree of the polynomial tells us how many answers there are. That doesn't hold. And a simple one like that might explode into 4 different answers. You might have 6 answers. You never know. You might have 8 answers. You never know. Gotta find them all. Huh? Oh, I like this one. You try it. So the classic math mistake here is you see sine on the left side, you see sine on the right side, so you should just be able to do this. Right? The downfall is that you want to do that. It's right there for you. It's like the low-hanging fruit. You just want to grab it and take a bite of that big red juicy apple. Okay? But here's the problem. You'll lose an answer or 2 or 3 or 4 every time you do that. Okay? So you're only getting part of the solution. You need, the only thing that we can do is factor. I know. Algebra 1 coming back to bite you in the patootie again here in pre-calc. Okay? So in order to do this, the first thing that I got to do is I've got to subtract sine from both sides. So that's going to give me either negative sine of x plus sine x tangent squared of x, or that's going to give me sine of x tangent squared of x minus sine of x equals 0. Now, it looks like that problem that we just did, and I can factor out a sine of x, leaving me with tangent squared of x minus 1 equals 0. Now I can set my factors equal to 0. Oops. Where first lap unit circle is sine equal to 0. First lap where sine equal to 0. 0 and pi. Tangent squared of x minus 1. I can add 1 to both sides. What can I do with tangent squared of x equals 1? Yes, sir? Square root both sides. If I square root both sides, what comes into play? The plus or minus comes into play. Okay? So, positive 1, where first lap unit circle is the tangent equal to positive 1. Pi over 4, I agree with. 5 pi over 4 is the other one that I agree with. First lap unit circle, where is tangent equal to negative 1? 3 pi over 4, 7 pi. So this one has 6 answers. 0, pi over 4, 3 pi over 4, pi, 5 pi over 4, and 7 pi. Lots and lots and lots of answers out of that. Questions, comments, concerns, clarifications? Had you divided I shouldn't say had you, if most of you would have continued on the path of bad maths from the start and dividing by sign, you would have gotten the pi over 4s, all 4 of them, but you would have missed out on the 0 and the pi. So your answer would have been incomplete. Okay? Factoring is the only thing that you can do. So, as I had said earlier, yesterday you should have gotten your second worksheet. Some of you have it on one single page, it's front and back, that's fine. Some of you have it on front side of one, front and back of the other. Okay, you can get rid of the one unless you've already done it down there. You know what I mean? You don't have to do the problems again, but they are, one side of the front and back is the same as the one that you got on Friday. Okay, if not, their sheets are over there by the door. Those will all be due from everyone. So you're going to have the both golden worksheets. You'll get another worksheet tomorrow, and you'll get a review on Friday of this week for this unit. All 4 of those are going to be due. Actually, you'll probably get a couple more too. So all of the homework will be due from everyone next week.